Good afternoon. I'm Dr.M. Kumar, SNS College of Technology, Innovator, DTCFC. In this session, we'll be learning about bridge rectifiers, an important topic in the subject of electric circuits and electron devices. As you all know, the most of our electronic gadgets like mobile chargers, radios, and computers run on DC, but the power from all our wall socket is AC. So we need a circuit called rectifiers to convert AC into DC. Among various types of rectifier, bridge rectifiers are known to be the most efficient. In this session, we'll learn what a bridge rectifier is, how it's being constructed, how it works, what its characters, and what advantages and disadvantages it has. Let's get with the basics. Let's look at how a bridge rectifier is built. Bridge rectifier is a circuit using four diodes, naming as D1, D2, D3 and D4, and it has the load resistance RL. These diodes are arranged in square or in a diamond shape. This arrangement is called as a closed loop bridge configuration. One more advantage of this bridge rectifier is it does need no need of center tapped transformer, which is often expensive and bulky. So it's cost effective and space saving. The AC input is applied to two positive corners of the bridge, and the output is taken from other two corners across the load resistor. The four diodes work together to convert both half of a AC signal into a unidirectional DC output. This is why the bridge rectifier is widely used. It gives better performance and uses full input waveform without needing special transformers. Now let's understand how the bridge rectifier works during the positive off cycle of an AC input. When the AC input is in the positive off cycle, the terminal A is positive and the terminal B is negative. In this condition, diodes D1 and D3 are forward biased, so they conduct. Diodes D2 and D4 are reverse biased so that they do not conduct. The current flows from the terminal A through D1 passes through the load resistor RL, then thus go through the D3. Finally, it returns to the terminal B. So even though the AC is an alternate, this diode arrangement allows current to flow in one direction only through the load. This is how we get a DC output from the positive off of the AC signal. In the negative off cycle of the AC input, the direction of voltage changes. Now the terminal B is positive and the terminal A is negative. In this case, diodes D2 and D4 are forward bias and conduct. Diodes D1 and D3 are reverse bias and do not conduct. The current flows from terminal B through D2, passes through the load resistor RL in the same direction as before. Then the D4 and back to terminal A. So during the positive and negative off cycle, the output current through the load flows in the same direction. This is how a bridge rectifier achieves full wave rectification without needing a center tapped transformer. It's like we are seeing the output waveform of a bridge rectifier. So this would given you the circuit, right? This is a circuit which contains a four diodes with a resistor load RL where the AC input is given. So in order to discuss on this output waveform, before rectification, the AC signal goes above and below the zero, alternating direction every off cycle. But after passing through the bridge rectifier, both positive and negative off wave of the AC signals are converted into positive off cycle. So now the output waveform is a series of positive humps. This is called pulsating DC. It's still not perfectly flat like a battery DC voltage, but the current flows only in one direction, which is suitable for many electronic applications. Later, we can add a filter like a capacitor to smoothen the waveform even more. But as you can see, even without a filter, the bridge rectifiers gives us a continuous stream of DC output during both cycles of AC. Now let's discuss the key characteristics of bridge rectifier, right? We were seeing on bridge rectifiers with the positive off cycle output and with the negative off cycle output, right? We will see the key characteristics like ripple factor, right? This tells how smooth or bumpy of the DC circuit is. A lower ripple factor means the smoother DC. For off wave bridge rectifier, it is full wave, it is 0.4, and it's for full wave off wave, it is 1.2, right? Then the efficiency is very good for bridge rectifier, it is around 81.2, wherein for off wave, it is around 40. So this is the output waveform of an AC the pulsating DC. AC input is given as a sine wave, and DC output is in the form of positive and negative off cycle combined or consolidated output, right? Which gives high efficiency, converts both of the off wave of AC input into DC, giving a better output than off wave rectifier. If there is a no center tapped transformer needed, this makes the design simple and cheaper. Use of input signal, it's like the off rectifier that wastes only one half of AC signal, but the bridge rectifier uses the entire input waveform. Also, the output of the DC is smoother and easier to filter, which is important for sensitive electronic devices. Because of these advantages, bridge rectifiers are commonly found in power adapters, batteries, and other DC power systems. And see on the characteristics of bridge rectifier like ripple factor, peak inverse, efficiency. Bridge rectifier is more good when compared to the off-air rectifiers. But even though they have few disadvantages, like they have more complex circuit, they have high voltage drop, and they have more power loss, right? Since we have used more diodes, that would be a dissipation of heat would be more. And despite of these drawbacks, the benefits like full wave usage and high efficiency make the bridge rectifier a preferred choice in the most of the electronics. To summarize what we have learned today, bridge rectifier uses four diodes to convert AC to DC using both half cycles of the input. It is efficient, does not require a center tapped transformer, and provides a smoother DC output voltage. It has a ripple factor of only 0.48 and an efficiency of 81.2. While it has slightly more complex circuit and higher voltage drop, its advantages make it more suitable for the most power supply applications. Thank you for your attention. If you have any question or need clarification, please post it in the comment box. Thank you. Catch you later in upcoming sessions.